All right, here are the half angle formulas. We're going to use the half angles formulas on this slide to be able to evaluate some trig expressions. So here are the sine, cosine, and tangent half angles. You do need to be careful when you identify the quadrant in which the half angle falls in. And that'll tell you if you have a positive or negative sign. And then we have two more half angle formulas for the tangent. So here's our example. We want to find the exact value for the cosine of 112.5 degrees. 112.5 degrees is not on the unit circle, but if we double it, so now let me write here. If we double that angle, we're at 225 degrees. So here is our four quadrants. So 112 degrees is about there. So there's 112.5 degrees. If we double that angle, 225 degrees, which is down here, we can use our half angle formula. So the formula we're going to use is the cosines half angle formula. So we're going to go up in our notes, and we're going to use this formula right here. So I'm going to write the formula down first. So the half angle formula for the cosine is alpha A over 2 equals plus or minus the square root of 1 plus the cosine of alpha over 2. So the angle is 112.5 degrees we want to find, but we're going to be using the 225 degrees as our alpha. So this is our alpha in our formula. So here we go. So the cosine of 225 degrees over 2 is 112.5 degrees equals, and I'm going to wait on the plus or minus for now, plus 1 plus 225 degrees over 2. Now our unit circle we did memorize in Unit 4. It has the ordered pair x comma y, negative square root of 2 over 2, comma, negative square root of 2 over 2. Remember, this is our cosine, and that's our sine. Well, we're going to work with the cosine value, and we're going to substitute it right into there. We're going to substitute that fraction into the cosine of 225 degrees. So we get 1 plus, and now that's negative square root of 2 over 2 over 2. The rest of this problem is a little bit tedious. It's a lot of simplifying. So let's talk about this numerator. This numerator has unlike fractions. That 1 can be rewritten as 2 divided by 2. 2 divided by 2 is 1. And then minus the square root of 2 over 2. And then all over 2. So what we're trying to do is we're trying to add these two fractions together. I can add them now because they're like denominators. So we get 2 minus the square root of 2 over 2, and then all over 2. And I'm going to change that bottom 2 to a fraction, so 2 over 1. So now I have a fraction dividing another fraction underneath that square root symbol, so I can keep change flip. So I have 2 minus the square root of 2, and then changing that to multiplication, and then flipping it. So I can multiply across. So I get 2 minus the square root of 2 over 4. Now that large radical can be separated into two separate radicals. So in the numerator, I have the square root of 2 minus, or square root of 2 minus the square root of 2, and then over square root of 4. This denominator right here can be simplified to just 2. All right, I did say we need to identify if it's a positive or negative sign. And that comes into play when we talk about this purple angle. This purple angle falls in quadrant 2. In quadrant 2, if you think about your ordered pairs x and y, or your cosine and your sine, the x in quadrant 2 always has to be a negative. So that means then our cosine, so that answer then is going to be a negative solution.